This is my end of quarter video for the project Orchestration Scripts. My name is Vishal, and before I dive into the work that I did this quarter, I'd like to talk about the motivation for this project in a little more depth. Perhaps the biggest motivating factor for orchestration scripts is to scale learning communities like that of DTR. Mentors have limited time to carry out their own research and complete their personal tasks and goals, while still having to ensure proper running of the research studio. A large part of the proper running of the studio is learning outcomes for undergraduate students carrying out their own research and guiding them to learn how to carry out their own research, especially because of the nature of the projects that undergraduate students do research on. Not only are there a variety of projects, but inherently, each student is at a very different stage of research. Some might be need finding, while some might be designing studies for their tech prototypes. The scripts would allow mentors to have a window into students' work processes, something that is not currently available. In its current state, there are two ways that mentors are able to gain visibility into student work processes: passive methods and active methods. Passively, there are studio artifacts that students use to guide and plan their work that mentors can observe at any time they need to, specifically with sprint logs and the practical and research canvases, as well as specific student deliverables that mentors ask students to complete. For example, a need finding protocol. In addition to that, the active methods, through one-on-one discussions at SIG meetings and office hours, mentors can observe a student's work patterns and diagnose their blockers with the students. In the ideal state, we want the passive methods to inform mentors of student work patterns in a more exhaustive way. We want to enable mentors to write scripts that are able to actively monitor a student's work patterns, passively detect ineffective practices, and provide students with just-in-time feedback that is able to help them self-direct and overcome blockers without mentor intervention. The script would take the form of a goal that a mentor wants to accomplish, a specific condition in a student's work patterns that is able to be detected, and specific feedback that would be given to the student to help overcome their blocker. One specific example of this would be an intermediate deliverable post-SIG. If a student and mentor agree upon a specific deliverable for next week's SIG, a mentor might ask a student to send a smaller slice of that deliverable somewhere during the week. The goal for this would be ensuring that students are not committing too much time on unnecessary tasks without the proper direction. The condition would be if a planned intermediate deliverable was agreed upon and if it wasn't sent to the mentor, and the feedback for it would be to prompt the student to complete and send a deliverable. This is an example that will come up multiple times in this presentation and is a very basic representation of what orchestration scripts aim to accomplish. Another quick example to start thinking about the problem more deeply is ensuring that students are editing their sprint log consistently throughout the week to accurately reflect the work they're doing, but also to promote good planning and replanning practices based on findings that students come across in their research on a week-to-week basis. Thinking about the problem space and the question that orchestration scripts aims to answer: how do mentors scale learning communities while maintaining the quality and effectiveness of learning that each student experiences? Thinking about the design argument for orchestration scripts that I've been thinking about, working backwards from the outcomes, mentors want to be able to teach students the needed skills to work effectively in networked orchestration. That would be the regulation skills to help students actually direct their own research. The obstacles in the way of that are that mentors do not have the time to understand and guide students' work and learning between times of meeting. So passive methods of detection are not effective enough currently. And the characteristics of a potential solution would be to enable mentors to encode their existing mentoring strategies used to identify ineffective practices into machine executable programs using studio data. Delving into the work that I did this quarter, firstly was need finding. I wanted to understand how mentors went about orchestration currently. the mentoring strategies to identify ineffective practices were unclear to me, and I wanted a few robust cases of where mentors orchestrated their students. In addition to that, I wanted to understand why it was difficult to orchestrate, specifically, why it's difficult to detect ineffective practices without a discussion that would allow a mentor to diagnose it themselves. I wanted to get cases around which the biggest challenge would be supporting the encoding process. So not thinking about existing links to passive detection methods, but rather what mentors were able to detect in person that I could abstract into passive detection. From the core findings, with respect to goals, I learned that strategies that mentors go about are not necessarily generalizable to all mentors. Different goals are prioritized differently based on their style of mentoring. And orchestration itself looks very different to each mentor depending on their specific style of mentoring. The biggest takeaway, however, was with detecting conditions for orchestration. Evidently, a large part of detection happens in person when a student and mentor are able to collaborate and reflect on work done over a week. This makes it extremely difficult to detect ineffective practices purely through studio data. And in addition to that, the conditions often vary with mentor expectations of their student. So whether a student is relatively new in DTR or an experienced DTR student, and they also vary a lot with student-specific work patterns. And in addition to sort of how a student works, also the other commitments that a student has. So the number of classes they're in, extracurricular commitments throughout the quarter, etc. Some of the questions that I've been thinking about through this need finding are, 1, how do we detect ineffective practices passively? And 2, how specific are detectors to an individual student's work patterns? Once I had a few fleshed out cases, my next step was to explore a specific goal in more depth. One that came up in multiple interviews was slicing. Encouraging students to break down large nebulous problems into smaller slices and receiving feedback early to guide the rest of their work. When thinking about the design arguments for slicing, considering the same outcome and obstacle, the characteristics are as follows. The solution would scaffold students to work in slices and receive feedback from mentors, resulting in mentors spending less time diagnosing a student's work patterns during times of meeting, as well as providing just-in-time feedback to students on smaller slices of work. I wanted to understand why it was difficult for students to slice their work and receive feedback on it earlier, and why it was difficult for mentors to detect whether a student was slicing their work effectively. During my status update, during week 9, I was able to conduct a survey on both students and mentors, which gave me a little bit of insight on slicing specifically. The core findings from the student side are students don't typically slice unless asked, and they often struggle to ask for help on smaller slices, especially newer students. Some of the reasons are they're conscious of mentors' time, or they think they're disrupting the process with incomplete work, or they're stuck in a rabbit hole. But oftentimes I think students are unable to complete their smaller slice in a timely manner and give it to mentors for them to provide feedback. And often students also agree that earlier just-in-time feedback is more effective in the work process and helps them guide the rest of their work for the week and the quarter. Specific to mentors, I learned that slicing is a goal that students are encouraged to follow, not only when asked. It is very difficult to detect during the week, with the mentor even saying that it's challenging to recognize when I should help students slice because I think about milestones in larger chunks. With regards to next steps, I want to understand how I can support mentors in encoding slicing as an orchestration goal. So when a mentor and student agree on an intermediate deliverable, how could an orchestration script or any form of a script allow for mentors to encode this and then enforce this intermediate deliverable to be sent and feedback given back to the student? I would like to thank the entire DTR community for all their help throughout this quarter and for supporting me in the work that I did, and especially Kapil, my SIG head, for guiding me through such an uncertain process of undergraduate research. Thank you.